Okay, so the recording has started. Let me start with today's lecture. Today we are going to cover the topic of impact, and primarily we will be focusing on the topic of central impact in today's class. Probably oblique impact is going to be covered in next week class because as you all know that today we are going to have quiz number 5 as well. Just a quick review of what we did up till now in this chapter. Initially, we covered the topic of principle of impulse and momentum, which states that the initial momentum of a particle plus sum of all the impulses that are acting on the particle from time t1 to t2 should be equal to the final momentum of a particle. Then in the next topic, which is the conservation of momentum principle, we considered the interaction between two particles, since the conservation of momentum principle is always applied when two particles interact or collide with each other. Once you are applying this conservation of momentum principle, the condition for applying this principle is that there should not be any external impulsive force acting on the system during that interaction. So in whatever direction there is no external impulsive force, you can apply this conservation of momentum principle along that axis. This principle states that the initial momentum of the system should be equal to the final momentum of the system, provided that there is no external impulsive force acting on the system along that axis during that interaction. Now this conservation of momentum principle, as we have already said, that it is applied when two particles collide or interact, and you need to draw the free body diagram of the system. While drawing the free body diagram of the system, it should be noted that all those forces which are internal to the system should have a net effect of 0 because they occur in equal and opposite collinear pairs as per Newton's third law of motion. So those internal forces will have a net effect of 0, and therefore they should not be included in our impulse and momentum analysis. Moreover, there are going to be some forces which are producing a very small amount of impulse, such as the weight or the force of an elastic spring. So they should also be neglected while considering the impulse and momentum analysis. इसके मुकाबले में you need to consider only impulsive forces, that is forces which create large amount of impulse in your impulse and momentum analysis. We did solve a few examples and problems relevant to this topic in our yesterday's class. Today, inshallah, we are going to start with the impact analysis. Now, all those problems which we have considered during our previous topic of conservation of momentum were of the form that once these two particles interact, after interaction, they are going to combine together and they are going to move with a common velocity. That is, we did not consider the rebounding of particles after the interaction. Rather, we considered that after interaction, these two particles are going to combine together and the whole system is going to move with a common velocity. However, in actual practice, we can observe that once two particles collide, then after collision, they are going to rebound in different directions with different velocity. So that topic is going to be covered in this impact analysis, which we are going to start today. Okay, so starting with today's topic, which is impact. First of all, let us discuss the definition of impact, the types of impact, and then we will focus on central impact in today's lecture. So impact occurs when two bodies collide with each other during a very short interval of time, causing relatively large impulsive forces to be exerted between the bodies. So impact हम कब कहते हैं? Impact occurs when two particles or two rigid bodies collide with each other during a very short interval of time, thereby causing relatively large impulsive forces to be exerted between the bodies. For example, the striking of hammer and a nail. जब भी आप hammer और nail को strike करते हैं तो क्या होता है कि hammer nail को strike करने के बाद it is going to rebound back. So the striking of hammer and nail or golf club and ball or bat and ball are common examples of impact loading. So these are the examples of impact loading. Now there are two types of impact. The first one is central impact, which we are going to focus today. The other one is oblique impact, which inshallah we are going to cover in next week's class. So what is the difference between central and oblique impact? Let us first of all discuss the definitions, and then we will derive some mathematics relevant to central impact. Okay, central impact occurs when the direction of motion of mass centers of the two colliding particles is along a line passing through the mass centers of these two particles. This line is termed as the line of impact. However, when the motion of one or both of these particles is at an angle with respect to that line of impact, the impact is then termed as oblique impact. These are the two figures which shows examples of central or oblique impact. Let us discuss these definitions one by one. I hope that a blank slide is visible to all of you.
Yes, sir.
Yes, sir.
Okay, now in order to differentiate between central and oblique impact, let us consider a particle, say this particle which is particle A, and it is traveling with some velocity, say VA1 towards the right. Then we have another particle, say particle B, which is traveling towards the left with a velocity of say VB1 towards the left. Since these two particles are traveling opposite to each other, that is towards each other, so definitely they are going to collide at some stage. Now during collision, what would be the scenario? This would be the scenario when these two particles are going to collide. This is particle A, this is particle B. So at the time of collision, you join the mass centers of these two particles. So these are the two mass centers shown to you. So once you join the mass centers of these two particles, you are going to get a line which is termed as the line of impact. So जब भी आपसे कहा जाए कि what is the line of impact? So line of impact is basically an axis or a line which can be obtained by joining the mass centers of the two colliding particles at the time of collision. At the time of collision, आप इनके mass centers से join करेंगे तो जो भी line आपको मिलेगी, that line is basically termed as the line of impact. इसके मुकाबले में जो second axis है या जो second line है, it is defined as the plane of contact. वो plane of contact क्या होता है? The plane of contact is basically an axis or the line which is defined perpendicular to the line of impact at the time of collision. So ये वाली जो आपको यहाँ y axis के तौर पे शो की जा रही है, this is basically the plane of contact. तो सबसे पहली बात तो ये कि इन दोनों लाइंस को समझना बहुत इंपॉर्टेंट है, बिकॉज इन्हीं लाइंस की बेसिस पे आपके इम्पैक्ट की डेफिनेशंस और इम्पैक्ट की एनालिसिस जो है वो की जाती है. तो मैं दोबारा रिपीट कर देता हूँ. व्हाट इज द लाइन ऑफ इम्पैक्ट? द लाइन ऑफ इम्पैक्ट इज बेसिकली एन एक्सिस व्हिच वी कैन ऑब्टेन बाय जॉइनिंग द mass centers of the two colliding particles at the time of impact. At the time of collision. So line of impact आपको इस तरह मिल जाएगी. The plane of contact which is defined to be an axis that is drawn perpendicular to the line of impact at the time of collision. So ये आपके पास plane of contact आ जाएगा. Okay, now how you are going to differentiate between central and oblique impact, because the procedure for analysis of both types of impact is different from each other. So first of all, you need to identify कि ये जो impact हो रहा है ये किस कैटेगरी में आता है, और फिर उसी हिसाब से उसकी मैथमेटिक्स, उसकी इक्वेशंस जो है वो हम अप्लाई कर सकते हैं. ओके, नाउ व्हाट इज सेंट्रल इम्पैक्ट? सेंट्रल इम्पैक्ट की अगर हम डेफिनेशन देखें तो सेंट्रल इम्पैक्ट की डेफिनेशन क्या कहती है कि इफ बोथ these particles were traveling along the line of impact before collision, then that particular type of impact is termed as central impact. यानी central impact से क्या मुराद है कि collision से पहले अगर ये दोनों particles इसी line of impact के along travel कर रहे थे, यानी इनका momentum इसी line of impact के along था, तो then that type of collision is basically termed as central impact. Central impact की definition हर एक को clear हो गई है?
Yes, sir.
Okay, so just a quick review कि central impact क्या होता है? It is an impact in which both the colliding particles were traveling along the line of impact before collision. इसके मुकाबले में अगर हम oblique impact की बात करें तो oblique impact क्या होता है? When one or both these particles are traveling with respect to the line of impact at some angle, then that particular type of impact is termed as oblique impact. For example, मैं आपसे कहता हूं कि आपके पास particle A जो है, it was not traveling from the position shown to you earlier. Rather, this particle A was located at this position and it was traveling at a velocity VA1 at an angle of say θ1 with respect to the line of impact. At the time of collision, आपने जब line of impact बनाई तो वो यही blue वाली line बनी थी. Since particle A has a velocity which is at an angle with respect to the line of impact, so basically now this type of impact would be called oblique impact. इसी तरह अगर मैं particle B की बात करूं, मैं कहूं कि particle B जो है वो instead of traveling from this location, let us say that this particle B was located at this location, and it was traveling with a velocity VB1 at an angle of say phi1 with respect to the line of impact. So at the time of collision, this is the line of impact which is shown to you by the blue line. Since now both these particles are traveling at an angle with respect to the line of impact before collision, so it is an example of oblique impact. तो oblique impact में एक या दोनों particles line of impact के along travel करने के बजाय किसी angle पे line of impact से जो है वो collision से पहले travel कर रहे होते हैं. So that particular type of impact is termed as oblique impact. I hope that now the definition of central and oblique impact are clear to all of you.
Yes, sir.
Yes, sir.
Okay. So in case of central impact, since the particles were traveling along the line of impact before collision, so after collision भी ये line of impact के along ही जो है वो travel करते हैं. So rebound होंगे या collide होने के बाद line of impact के along ही travel करेंगे. If you are considering the case of central impact, it means that the number of unknowns which are involved in case of central impact are the magnitudes of final velocities. Initial collision से पहले वाली velocities आपको known होती हैं. So there are just two unknowns which are the magnitudes of final velocities after impact. However, in case of oblique impact, न सिर्फ इनकी velocities unknown होती हैं बल्कि इनके collision के बाद वाले angles भी unknown होते हैं. So the number of unknowns are going to be 4. That's why the procedure for analysis of central and oblique impact is different from each other, because in case of central impact you are going to have two unknowns, that is the magnitude of final velocities, whereas in case of oblique impact not only the magnitudes of final velocities are unknown to you, but the angles or the direction of these velocities are also unknown to you. So overall, you are going to have 4 unknowns in case of oblique impact. It means that you require 4 equations in order to find out those 4 unknowns. Okay, now let us consider another simple example in which I say that you have a horizontal surface as shown to you here, and then you have a particle which is say particle A, which is traveling towards the right as we have discussed earlier as well, and you have an identical particle which is particle B, which is traveling towards the left as shown to you. Now once these two particles collide, so once A collides with B, what would be the case? Is it a case of central impact or oblique impact?
Central impact.
If the particles are identical, then it would be a case of central impact. However, if I say that this particle A is in the shape of a sphere having a radius of say RA, and then you have another particle which is particle B, which is shown to you here. This particle B has a radius of RB, which is say different than RA. That is, you have two unidentical particles as shown to you in the figure. Now, once these two particles collide, what should be the case now? Is it a case of central impact or oblique impact now?
Sir, central impact क्योंकि
now this is going to be the line of impact, isn't it? The blue line which I have shown by joining the mass centers. So since both the particles were traveling along this line of impact?
No, sir.
So now if you have two particles which are not identical to each other and they are going to collide, then it would become a case of oblique impact rather than central impact. ठीक है? तो आपके पास situation को देखते हुए you need to first of all identify the type of impact. कि is it a case of central impact or is it a case of oblique impact? And based upon that definition, आप फिर उसकी analysis करते हैं, because if it is a case of central impact, then you need to apply the procedure for analysis of central impact. If it is a case of oblique impact, then the procedure is going to be different. So first of all, based upon the figure, you need to identify is it a case of central impact or oblique impact, so that you can accordingly apply the correct procedure for analysis of that problem. Is this point clear to all of you?
Yes, sir.
Yes, sir.
Chaliye, now moving to the analysis of central impact. First of all, we are going to consider two particles. One is particle A as shown to you in this figure here. This particle A is traveling with a velocity or momentum MAVA1 towards the right as shown to you here. Then you have another particle B which is traveling towards the right as well with a momentum of MBVB1. So we have taken a general case in which both the particles are traveling towards the right, provided that VA1 is greater than VB1, that is the velocity of particle A is greater than the velocity of particle B, ultimately at some point the collision is going to take place. So this is a general case in which we have considered both the particles traveling towards the right. However, in actual problems, maybe particle B would be traveling towards the left. So once you are applying the momentum equations, you can accordingly change the sign of momentum to the negative sign if you are taking the positive axis towards the right. So we are taking a general case in which we have two particles, both of them traveling towards the right with velocities VA1 and VB1 respectively, and VA1 is greater than VB1, so ultimately collision is going to take place. Consider a case involving central impact of two smooth particles. The particles have initial momenta as shown to you. Provided that VA1 is greater than VB1, collision will eventually occur. So before moving on to developing the mathematics for this central impact, first of all, let us understand what happens during this central impact, or what is the actual physical phenomena involved during this central impact. Okay, first of all, once that collision has started, during collision, the materials of the particles must be thought of as deformable or non-rigid. कि सबसे पहली बात तो ये कि collision के दौरान we are going to consider these two particles to be deformable and non-rigid. Deformable से क्या मुराद है कि इसमें थोड़ी बहुत deformation होगी, उसके बाद फिर material properties involve होंगी जो कि इन particles को अपनी original shape पे वापस लाना चाहेंगी, और फिर ये particles उसी original shape पे वापस आने की वजह से separate हो जाएंगी और मुख्तलिफ velocities के साथ rebound होके मुख्तलिफ directions में along the line of impact जो है वो travel करेंगे. So the particles first of all will undergo a period of deformation such that they exert an equal and opposite deformation impulse on each other along the line of impact. सबसे पहले क्या होगा? When the collision starts, the particles, each particle will exert an equal and opposite deformation impulse on the other particle along the line of impact. But this deformation impulse is going to be internal to the system. कि अगर मैं इस पूरे system को consider करूं, so then this deformation impulse is going to be internal to the system. However, अगर मैं किसी एक particle की free body diagram बनाऊं, तो फिर दूसरा particle इस पे जो impulse exert करेगा वो external to the particle हो जाएगी. So first of all, there is going to be a deformation phase in which both particles are going to exert an equal and opposite deformation impulse on each other along the line of impact. Then only at the instant of maximum deformation will both particles move with a common velocity. अब होगा क्या कि एक स्टेज ऐसा आएगा जिस पे ये पार्टिकल्स मैक्सिमम डिफॉर्म हो चुके होंगे. उस स्टेज पे आपका ये पूरा सिस्टम जो है वो एक कॉमन वेलोसिटी से सिर्फ थोड़े टाइम इंटरवल डेल्टा टी अप्रोचेस टू जीरो के लिए मूव करेगा. देन the restitution phase will occur in which each and every particle would exert an equal and opposite restitution impulse on the other particle. As a result of this restitution impulse, both these particles are going to separate. Restitution क्या होती है कि वो material अपनी original shape जो है उस पे वापस आने की कोशिश करेंगे, जिसकी वजह से ये restitution impulse exert होगा. ये restitution impulse इन दोनों particles को separate कर देगा, and after separation, both these particles are going to move towards the right with velocity VA2 and VB2. In this case, VB2 is greater than VA2. यानी अगला पार्टिकल हो सकता है ज्यादा तेज निकल जाए और पिछला पार्टिकल में भी स्लो हो जाए या रुक जाए. वो डिपेंड करता है कि आपकी कोलिजन जो है वो किस टाइप की हुई है, कितनी एनर्जी लॉस हुई है उस पहले पार्टिकल की. तो हम जनरल केस कंसिडर कर रहे हैं कि कोलिजन के बाद बोथ द पार्टिकल्स आर गोइंग टू मूव टुवर्ड्स द राइट, बट नाउ VB2, which is the velocity of particle B after collision, is going to be greater than VA2. So overall, this whole central impact can be divided into two phases. The first one is the deformation phase, in which each particle exerts a deformation impulse on the other particle. Then it would be a restitution phase in which each particle is going to exert restitution impulse on the other particle, but these deformation and restitution impulses are internal to the system because they occur in equal and opposite collinear pair as per the Newton's third law of motion. So this is the whole physical phenomena of central impact. I hope that all these steps are clear to all of you. Now we are going to move towards the mathematics, but first of all ये आपको physical phenomena समझ आ गया है कि क्या होता है central impact में?
Yes, sir.
ठीक है. Okay, now once you have understood the physical phenomena involved in central impact, let us now move towards the mathematics which is being involved in case of central impact. In order to develop mathematics, let us consider the same central impact phenomena, और हम थोड़ी सी mathematics इसकी develop करने की कोशिश करते हैं. In this regard, when we are considering the central impact, in most problems, the initial velocities of these particles will be known to us. Initial velocity से क्या मुराद है कि the velocities of both the particles before collision is generally known to us in all the problems, and we are required to determine the final velocities of these particles, that is आफ्टर कोलिजन ये पार्टिकल्स कितनी वेलोसिटी से जो है वो ट्रेवल करेंगे. इन अदर वर्ड्स Va1 और Vb1 हमें नोन होती है, विच आर द वेलोसिटीज ऑफ पार्टिकल्स बिफोर कोलिजन, और Va2 और Vb2 जो है वो अननोन होती हैं, विच आर द वेलोसिटीज ऑफ दीज पार्टिकल्स आफ्टर कोलिजन. नाउ इन दिस रिगार्ड, इफ वी कंसिडर the system, that is if we consider both these particles as a system, तो उस सिस्टम पे ड्यूरिंग द डिफॉर्मेशन और रेस्टिट्यूशन फेज क्या कोई एक्सटर्नल इंपल्सिव फोर्स एक्सर्ट हुई है?
नो सर.
जितना भी उसके ऊपर इंपल्स आ रहा है वो सारे के सारा इंटरनल टू द सिस्टम है, चाहे वो डिफॉर्मेशन इंपल्स है या वो रेस्टिट्यूशन इंपल्स है. सो देयर इज नो एक्सटर्नल इंपल्सिव फोर्स एक्टिंग ऑन द सिस्टम along the line of impact during collision. So we can say that the system's momentum has been conserved along the line of impact. So applying the conservation of momentum principle on the system along the line of impact, taking positive towards the right, the conservation of momentum principle says that the initial momentum of the system should be equal to the final momentum of the system, provided that there is no external impulse acting along that axis. So we are considering the line of impact. जो भी इंपल्स है वो सारे के सारा इंटरनल टू द सिस्टम है, बेशक वो डिफॉर्मेशन इंपल्स है जो पेयर्स में आकर हो रहा है या वो रेस्टिट्यूशन इंपल्स है जो पेयर में आकर हो रहा है. सो सिंस देयर इज नो एक्सटर्नल इंपल्सिव फोर्स एक्टिंग ऑन द सिस्टम अलोंग द लाइन ऑफ इम्पैक्ट, इट मींस दैट द सिस्टम्स मोमेंटम हैज बीन कंजर्व्ड along the line of impact. So applying that conservation of momentum principle, which says that the initial momentum of the system, which is MAVA1 plus MBVB1, should be equal to the final momentum of the system, which is MAVA2 plus MBVB2. So let us call it as equation number 1, which has two unknowns, Va2 and Vb2. It means that in order to solve this system, we should be requiring one more equation in terms of Va2 and Vb2, so that the system of equations can be solved simultaneously. यहाँ तक clear है हर एक को point?
Yes sir.
Okay, in order to derive the next equation in terms of Va2 and Vb2, let us consider particle A alone rather than the system. So in order to obtain a second equation necessary to solve for Va2 and Vb2, we must apply the principle of impulse and momentum to each particle along the line of impact. कैसे? सबसे पहले let us consider particle A, and we are going to apply the principle of impulse and momentum on particle A during the deformation phase. Deformation phase क्या था कि deformation phase से पहले ये particle जो है वो इतनी velocity से move कर रहा था, ये वो deformation phase आया, और इस deformation phase के बाद this particle A was traveling with a velocity v. So applying the principle of impulse and momentum on particle A during this deformation phase along the line of impact, the principle of impulse and momentum says that the initial momentum of particle A before the deformation phase plus sum of all the impulses that are acting on particle A during this deformation phase should be equal to the final momentum of this particle A after this deformation phase. Deformation phase से पहले particle A का momentum MAVA1 था. Particle A की अगर मैं deformation phase की free body diagram बनाऊं तो इंटीग्रल P dt जो है ये वो इम्पल्स है जो पार्टिकल B पार्टिकल A के ऊपर एक्सर्ट कर रहे हैं. सो इसको मैंने नेगेटिव साइन के साथ क्यों शो किया? बिकॉज इट इज टुवर्ड्स द नेगेटिव साइड ऑफ दिस लाइन ऑफ इम्पैक्ट, और ये वो मोमेंटम है पार्टिकल A का आफ्टर द डिफॉर्मेशन फेज. इज दिस स्टेप क्लियर टू ऑल ऑफ यू?
सर इंटीग्रल P वाला दोबारा समझा दें.
देखें, ये इंटीग्रल P वही चीज़ है जो इससे पहले अगर आपको याद हो हमने इन तमाम चीज़ों में, इन तमाम प्रॉब्लम्स में जो कंजर्वेशन ऑफ मोमेंटम के थे उनमें जब हम सिंगल पार्टिकल की फ्री बॉडी डायग्राम बनाते थे तो हम उस पार्टिकल के ऊपर दूसरा पार्टिकल जो इम्पल्स एग्जर्ट कर रहा होता था उसको एक्सटर्नल इम्पल्स के तौर पे लेते थे। बिल्कुल इसी तरह जब हम डिफॉर्मेशन फेज कंसिडर कर रहे हैं विच इज दिस पर्टिकुलर फेज, अगर मैं पार्टिकल ए की फ्री बॉडी डायग्राम बनाऊं डिफॉर्मेशन फेज के लिए तो दिस इज पार्टिकल ए, पार्टिकल बी इसके ऊपर जो है वो इंटीग्रल पी डी टी जो है वो इम्पल्स एग्जर्ट कर रहा है और नेगेटिव साइन क्यों आए, बिकॉज वी आर टेकिंग पॉजिटिव एक्सिस टुवर्ड्स द राइट। इज दिस पॉइंट क्लियर?
Yes, sir.
So once we are considering the deformation phase for particle A, this is the momentum of particle A before that deformation phase. This is the impulse which this particle B is exerting on particle A, integral P dt. और मैंने इसको negative sign क्यों दिया? Because that impulse is going to act towards the negative side of line of impact. और ये इस particle A का momentum है after the deformation phase. Similarly, in the next step, इसको मैंने इक्वेशन नंबर 2 का नाम दे दिए। इन द नेक्स्ट स्टेप मैंने पार्टिकल ए के ऊपर ही रेस्टिट्यूशन फेज के ऊपर प्रिंसिपल ऑफ इंपल्स एंड मोमेंटम अप्लाई किया। वो रेस्टिट्यूशन फेज क्या है? रेस्टिट्यूशन टू एक्सर्ट ऑन पार्टिकल ए द रेस्टिट्यूशन इंपल्स, और रेस्टिट्यूशन फेज के बाद ये वो मोमेंटम है जिसके साथ पार्टिकल ए जो है वो ट्रेवल करेगा आफ्टर सेपरेशन। सो अप्लाइंग द प्रिंसिपल ऑफ इंपल्स एंड मोमेंटम ऑन पार्टिकल ए नाउ अलोंग द रेस्टिट्यूशन फेज, this was the initial momentum of this particle before the restitution phase. This is the impulse which particle B is exerting on particle A along the line of impact, and this is the final momentum of particle A after the restitution phase. So ये मैंने इक्वेशन नंबर 3 इसको नाम दे दिया। दोबारा मैं रिपीट करता हूँ। In the very first step I have considered particle A and particle B to be a system, and I have applied the conservation of momentum principle on this system along the line of impact, since there is no external impulsive force acting along the line of impact on this system. So the conservation of momentum principle is being applied. In the next step, I have considered particle A alone, and I have applied the principle of impulse and momentum on particle A during the deformation phase, similarly during the restitution phase. So I hope that equation number 2 and 3 are clear to all of you.
Yes, sir. Yes, sir.
ठीक है? Okay, now there is a term which is known as the coefficient of restitution. So coefficient of restitution जिसको हम E से भी denote करते हैं, this coefficient of restitution is basically defined as the ratio of restitution impulse to deformation impulse. कि हम E को define कैसे करते हैं? E is basically defined as the ratio of restitution impulse to deformation impulse, that is integral r dt over integral p dt. अब integral r dt और p dt की वैल्यूज हमारे पास कहां से आएंगी? From equation number 2 we can determine the value of integral p dt which comes out to be MAVA1 minus MAV. ऐसे ही है?
Yes, sir. Yes, sir.
From equation number 3 we can find the value of restitution impulse to be equal to MAV minus MAVA2, isn't it?
Yes, sir. Yes, sir.
Okay, so from equation number 2 and 3 we can find the values of P dt and R dt. So putting those values in this ratio formula, which is the coefficient of restitution, we are going to get this equation, which is equation A, which is equal to V minus VA2 over VA1 minus V. So I hope that this इक्वेशन कहां से आई, कैसे डिराइव हुई, हर एक को क्लियर है?
यस सर। यस सर।
मैसेज कहां गए इसमें से?
सर दोबारा रिपीट कर।
मैं कह रहा हूं इसमें से एमए कहां गया?
रेशियो है, सेम पार्टिकल है, मास कैंसिल हो जाएगा।
That's correct. So numerator डिनोमिनेटर दोनों में से mass हम कॉमन ले लेंगे और ऊपर नीचे से कैंसिल कर देंगे because it represents the particles mass ma. So कैंसिल हो जाएगा and we are going to get E in terms of velocities, which is V minus VA2 over VA1 minus V. So I hope that this equation A and how it is being derived is clear to all of you.
Yes, sir.
Okay. Now repeat steps from this point onwards on particle B as well, कि जिस तरह आपने particle A को individually consider करके पहले deformation phase में, उसके बाद restitution phase में principle of impulse and momentum apply किया था और उसके बाद आपने coefficient of restitution find किया था. So repeat these all steps from this point onward on particle B as well. So once you apply the same steps on particle B, you are going to get an equation of this form E equal to VB2 minus V over V minus VB1 for particle B as well. So you are going to first of all consider particle B and apply the principle of impulse and momentum on particle B during the deformation phase, then during the restitution phase, and then finding E to be equal to R dt over P dt, and you are going to get VB2 minus V over V minus VB1. So कर लेंगे ये तीनों स्टेप्स पार्टिकल बी के ऊपर.
Yes, sir.
ठीक है. ओके, नाउ नेक्स्ट स्टेप इज हम इस पूरे सेंट्रल इंपैक्ट में किस चीज में इंटरेस्टेड है, क्या चीज फाइंड करने में इंटरेस्टेड है सेंट्रल इंपैक्ट में?
Final velocities.
Velocities after collision, isn't it?
Yes, sir.
तो ये v हमारे किसी काम का है? ये तो हमने जस्ट एक इंटरमीडिएट वेरिएबल डिफाइन किया था कि जब मैक्सिमम डिफॉर्मेशन होगी तो सिस्टम जो है वो इतनी वेलोसिटी से मूव करेगा, फिर रेस्टिट्यूशन इंपल्स आएगा जो इसको सेपरेट कर देगा. सो वी आर नॉट एट ऑल इंटरेस्टेड इन फाइंडिंग दैट मैक्सिमम डिफॉर्मेशन वेलोसिटी v. सो एलिमिनेटिंग दिस v फ्रॉम इक्वेशन नंबर a and b would get E to be equal to VB2 minus VA2 over VA1 minus VB1. So from equation A and B, we are going to eliminate V. कैसे eliminate करेंगे, कुछ idea है?
सर दोनों को कॉमन ले लेंगे, यानी कि इक्वल रख देंगे इक्वेशंस को.
हाँ, उसमें से V को हम निकाल लेंगे और फिर दोनों V की वैल्यूज को कंपेयर कर लेंगे. You are going to eliminate that V from that equation. Is it clear to you?
Yes,
तो
sir.
चलिए इसको एज अ नॉन सबमिटेड होमवर्क के तौर पे इस मैथमेटिक्स को लें कि किस तरह आपने इनको जो है वो सेपरेट करना है, v को एलिमिनेट करना है. ठीक है?
Yes, sir.
ठीक है. सो वंस यू एलिमिनेट v फ्रॉम इक्वेशन a and b, you are going to get the equation for this coefficient of restitution to be equal to vb2 minus va2 over va1 minus vb1. Okay, now my next question is, what does this VB2 minus VA2 represents?
Sir, difference in the final velocities.
इस डिफरेंस को हम कोई खास टर्म कहते हैं? रिलेटिव वेलोसिटी क्या होता है? अगर मैं रिलेटिव वेलोसिटी VBA कहूं तो व्हाट शुड बी VBA?
VB minus VA.
VB minus VA, ऐसा ही है. तो ये न्यूमरेटर जो है वो क्या रिप्रेजेंट कर रहे हैं? आप जरा तफसील से बता सकते हैं?
Relative velocity.
Relative velocity of the
Final.
It is basically representing the relative velocity of these particles just after collision, isn't it?
Yes, sir.
Okay, what about the denominator? What does this represent?
Sir, what is with respect to दूसरा particle?
It again represents the relative velocity of these particles just before collision. So basically आपका जो coefficient of restitution होता है, it is equal to the ratio of the relative velocity of these particles just after impact to the relative velocity of these particles just before impact. So आपका coefficient of restitution जब मुख्तलिफ particles collide हो रहे होते हैं उनके material के हवाले से coefficient of restitution is generally known to you for any collision. तो आपके पास एक second equation जो है, अब आपके पास दो इक्वेशन आ गई. वन इक्वेशन इज दिस वन जो कि आपको कंजर्वेशन ऑफ मोमेंटम से मिली थी इन टर्म्स ऑफ VA2 एंड VB2. द अदर इक्वेशन इज दिस वन जो कि आपको कोएफिशिएंट ऑफ रेस्टिट्यूशन से मिली है इन टर्म्स ऑफ VB2 एंड VA2. यू सॉल्व दीज टू इक्वेशंस simultaneously in order to get the values of VA2 and VB2. So इन दोनों इक्वेशंस को जब आप simultaneously solve करेंगे, you can get the values of exit और final velocities of these two particles just after collision. अभी हम बात करते हैं इस coefficient of restitution की तफसील के साथ, लेकिन जहां तक इन values को determine करने का ताल्लुक है, so these are the two steps which should be applied on each problem of central impact. First of all, आप उस सिस्टम को कंसिडर करके लाइन ऑफ इम्पैक्ट के अलोंग कंजर्वेशन ऑफ मोमेंटम की इक्वेशन अप्लाई करेंगे, जिससे आपको एक इक्वेशन इन टर्म्स ऑफ फाइनल वेलोसिटीज मिल जाएगी. In the next step, you are going to apply the coefficient of restitution equation along the line of impact in order to find out the second equation. Coefficient of restitution आपको तमाम प्रॉब्लम्स में नोन होता है, जिसकी मदद से आप इन दोनों इक्वेशंस को साइमल्टेनियसली सॉल्व करके अपनी फाइनल वेलोसिटीज का मैग्नीट्यूड जो है वो निकाल सकते हैं. यहाँ तक तमाम चीजें क्लियर हैं. उसके बाद फिर हम थोड़ा सा डिस्कस करते हैं इस coefficient of restitution को.
Yes, sir.
Okay, now since we have defined earlier that this coefficient of restitution comes out to be the ratio of relative velocities of the particle just before impact to the relative velocities of particles. Relative velocities of particles just after impact to the relative velocities of particles just before impact. Now, based on the value of E, you can define the type of collision as either elastic collision, प्लास्टिक कोलिजन और इलास्टोप्लास्टिक कोलिजन. ये तीन तरह की कोलिजन आपकी होती हैं. वन इज द इलास्टिक कोलिजन, द अदर वन आर द प्लास्टिक कोलिजन, एंड द थर्ड वन विच आर द मोर कॉमन वंस आर द इलास्टोप्लास्टिक कोलिजन. ओके, ये तीनों कोलिजन होती क्या हैं? सबसे पहले लेट्स टॉक अबाउट द इलास्टिक कोलिजन या इलास्टिक इम्पैक्ट की बात करते हैं. फॉर इलास्टिक इम्पैक्ट द वैल्यू ऑफ ई वुड बी इक्वल टू 1. वैल्यू ऑफ ई 1 के बराबर आने का मतलब क्या है? ये इक्वेशन क्या कहती है? वैल्यू ऑफ ई 1 के बराबर अगर आई है तो व्हाट डज फिजिकली इट मींस?
नो लॉस इन
सर
काइनेटिक
relative velocity is equal हैं दोनों सर before and after collision.
देखिए, कोएफिशिएंट ऑफ रेस्टिट्यूशन हमने डिफाइन कैसे किया था? इट इज बीइंग डिफाइंड एज द रेशियो ऑफ रेस्टिट्यूशन टू डिफॉर्मेशन इंपल्स. ऐसा ही है?
Yes sir.
सो ई इक्वल टू 1 का क्या मतलब है? आर डी टी और पी डी टी एक दूसरे के इक्वल हैं, isn't it?
Yes sir.
अच्छा, अगर रेस्टिट्यूशन इंपल्स और डिफॉर्मेशन इंपल्स एक दूसरे के बराबर हैं तो फिजिकली इसका क्या मतलब है? शुरू में आप में से किसी एक ने जवाब अभी स्टार्ट किया था.
सर नो लॉस इन काइनेटिक एनर्जी.
No loss in energy during that collision. So a collision is termed as perfectly elastic if the coefficient of restitution is equal to 1. That is, the restitution impulse is exactly equal to the deformation impulse. In other words, there isn't going to be any loss of energy during that collision. फिजिकली ये पॉसिबल है, आइडियल केस में तो हो सकता है, बट एक्चुअल केस में डेफिनेटली जब दो पार्टिकल्स कोलाइड होंगे, कुछ डिफॉर्म होंगे, आपकी कुछ एनर्जी जो है वो डिफॉर्मेशन में लॉस होगी, तो डेफिनेटली आपकी 100% इलास्टिक कोलिजन फिजिकली एग्जिस्ट नहीं करती है. सिर्फ आइडियल केस में तो हम कह सकते हैं, लेकिन फिजिकली 100% इलास्टिक कोलिजन जो है वो एग्जिस्ट नहीं करती है. इज दिस पॉइंट क्लियर टू ऑल ऑफ यू?
Yes sir.
Okay, the second type of collision is plastic collision, in which the value of E is equal to 0. What does the value of E equal to 0 represents from this formula E equal to integral R dt over P dt? कब ये 0 हो सकता है? अगर न्यूमरेटर 0 है या डिनोमिनेटर 0?
Numerator 0.
क्योंकि अगर डिनोमिनेटर 0 हो गया फिर क्या होगा? फिर तो E की वैल्यू किसके बराबर आ जाएगी?
Infinity हो जाएगी.
इंफिनिटी हो जाएगी, जो कि पॉसिबल नहीं है. सो E इक्वल टू 0 या प्लास्टिक कोलिजन कब होती है? जब R dt इक्वल टू 0 होता है. R dt अगर 0 हो गया तो फिजिकली किस चीज को वो रिप्रेजेंट कर रहे हैं?
रेस्ट को.
थोड़ा सा दोबारा सोचें. रेस्टिट्यूशन इंपल्स एक्ट नहीं कर रहा. मकसद क्या होता है रेस्टिट्यूशन इंपल्स का?
प्लास्टिसिटी, बेसिकली वापस उस पोजीशन पे
उन पार्टिकल्स को अपनी ओरिजिनल शेप पे वापस लाना और उनको सेपरेट करना. वो सेपरेट इसीलिए हो होते हैं कि वो जब ओरिजिनल शेप गेन करते हैं तो ये एक दूसरे के साथ सेपरेट भी हो जाते हैं. इट मींस के रेस्टिट्यूशन इंपल्स नहीं कर रहा. इसका मतलब क्या है?
सर permanently deform हो गए हैं.
Permanently deform हो गए. So a collision is said to be perfectly plastic when E equal to 0. That is, there is no restitution impulse given to the particles. So after collision, both particles couple or stick together, move with a common velocity with that particular deformation. वो डिपेंड करता है common velocity से मूव कर रहे हैं या रुक गए, डिपेंड करता है क्या है. बहरहाल उनमें डिफॉर्मेशन जो है वो परमानेंट डिफॉर्मेशन हो जाती है. वो अपनी शेप जो है वो परमानेंटली डिफॉर्म कर देते हैं, अपनी ओरिजिनल शेप पे वापस नहीं आते और एक दूसरे के साथ स्टिक हो जाते हैं. जनरली आपकी जितनी कोलिजन होती हैं दे आर इलास्टोप्लास्टिक कोलिजन, यानी द वैल्यू ऑफ ई इज गोइंग टू वेरी बिटवीन 0 एंड 1. 0 और 1, फॉर एग्जांपल मैं कहता हूँ 0.5 है कोएफिशिएंट ऑफ रेस्टिट्यूशन, तो इसका मतलब क्या है कि आपकी कुछ एनर्जी जो है वो उस कोलिजन में लॉस्ट होगी, बाकी एनर्जी जो है वो उनकी रिबाउंड वेलोसिटीज में जो है वो डिस्ट्रीब्यूट हो जाएगी. सो ऑल द कोलिजन जनरली आर of elastoplastic nature. That is, the value of coefficient of restitution is going to be between 0 and 1, which means that some of the energy is going to lose during collision, while the remaining energy is going to be acquired by these particles in rebounding, or that is in moving in different directions after the impact. So I hope that the whole procedure of central impact and its mathematics is clear to all of you now.
Yes sir.
कोई चीज जो आप इस सेंट्रल इम्पैक्ट के हवाले से पूछना चाहें, इसके फिनोमिना के हवाले से, इसकी मैथमेटिक्स के हवाले से. Okay, so quickly, the procedure for central impact is shown to you here. जैसे अभी हमने डिस्कस किया था, first of all, we are going to apply step number 1 on a system. That is, the conservation of momentum principle is going to be applied on the system along the line of impact. Then, in the second step, we are going to apply the coefficient of restitution equation along the line of impact. This will give you two equations, one from conservation of momentum, two from the coefficient of restitution. You are going to solve these two equations simultaneously in order to find out these unknown velocities VA2 and VB2. So जो भी आपका सेंट्रल इम्पैक्ट का प्रॉब्लम आए, आपने ये दो स्टेप्स उस पर करने ही करने हैं कि पहली स्टेप में कंजर्वेशन ऑफ मोमेंटम अप्लाई करनी है और सेकंड स्टेप में आपने कोएफिशिएंट ऑफ restitution अप्लाई करनी है. So these are the two steps which are going to be used for the analysis of any problem relevant to central impact. Is this point clear to all of you?